You know, when you think about human biology, it's really comforting to view the body as this incredibly resilient, perfectly engineered machine.
An absolute.
Like you get a cut and it heals, you break a bone, it knits back together. We trust the internal scaffolding that holds us all together.
Right. We just assume it works.
But if you look closely at certain moments in history, you realize our biological machinery actually has this massive fatal glitch perfectly hidden inside it.
Yeah, a glitch we're all walking around with right now.
Exactly. So, welcome to this deep dive for the Nova Daily Genetics series. Today, we're exploring a fascinating evolutionary mystery based on Chapter 10 of Dr. Daniel Wallerstorfer's book, Unlock Your Genes for Precision Health. We're looking at how a very distinct dietary shift, about 61 million years ago, caused a genetic flaw that ultimately doomed thousands of 18th century sailors.
It's just a remarkable piece of genetic history. I mean, our modern human bodies are still carrying the baggage of our ancient ancestors' environment. And the consequences of that baggage, they can be incredibly severe.
And to give you an idea of how strange this gets, we're going to unpack the terrifying reality that you, me, guinea pigs, and fruit bats all share this deadly genetic defect.
A defect that, surprisingly, the rats scrambling around in the bellies of pirate ships completely avoided.
Right. So to understand this glitch, we need to step back into a really harrowing historical reality. So the year is 1739, England and Spain declare war on each other, and Captain Commodore George Anson gets this fateful, ambitious assignment.
Right. He's ordered to take 8 ships and a massive crew of 1,800 men to the coast of South America.
Right.
The goal was to attack Spanish towns and capture a ship carrying silver from Acapulco to the Philippines.
But getting that fleet seaworthy was a logistical nightmare from the start, wasn't it?
Oh, a total nightmare. They spent 5 months just trying to get the ships ready to sail. And by the end of it, Anson was still short a few hundred men.
Because all the fit, able-bodied men were already drafted for the wider war effort.
Right. Exactly. So the Navy resorted to going to a hospital and discharging maimed, old, and mentally deranged veterans. They just forcibly drafted them into Anson's crew.
He stuck with the oldest and weakest men the Navy could find.
Yeah. And they spend the tail end of their preparations just sitting on these anchored ships, waiting to leave, eating nothing but ship rations. Finally, in September 1740, the 8 ships set sail.
And they cross the Atlantic, which takes 6 grueling months.
6 months.
For half a year, these men are living exclusively on preserved provisions. We're talking cured beef, biscuits, oatmeal, butter, cheese, peas, and beer.
And that extremely poor restricted diet is the catalyst for the medical horror that wiped out the crew. By the time the British fleet reached the southern tip of South America, the men were showing early signs of what was called the seafarer's scourge.
Which we know today as scurvy.
Right, a severe vitamin C deficiency.
Now, I have to ask about the mindset of the naval officers here, because the very first symptom of scurvy is this intense physical weakness. But history shows the higher-ups formed this completely erroneous hypothesis that laziness was the trigger of the disease.
Yeah.
Were they really just writing off this devastating physical collapse as a lack of work ethic?
They were. The historical disconnect was just staggering. The officers truly believed it was a moral failing or, a lack of discipline.
Wow.
But the men weren't being lazy. Their bodies were fundamentally breaking down at a cellular level. And after that initial profound weakness, the progression of the disease turns brutal.
This is horrifying.
Dark spots begin to develop under the skin. Minor abrasions simply stop healing. Their legs swell up massively.
So if you're one of those sailors, you are literally watching your own body turn against you.
Completely. As the deficiency deepens, even the slightest physical exertion causes a person to completely collapse. And there's one detail in the research that paints an unimaginably grim picture of that.
Oh, the scar tissue thing.
Yes. One sailor in Anson's crew had an old wound that had been completely healed for 50 years.
50 years?
50 years. And suddenly, that 50-year-old scar broke open, as if the injury had just happened. Sailors who had previously broken bones experienced those old fractures snapping again. And the bones simply wouldn't knit back together.
So your body essentially forgets how to stay healed. It's horrifying.
It really is. The Navy tried to treat it, but they were fumbling in the dark. They handed out a tincture of vinegar, which
naturally did absolutely nothing.
Right, nothing at all.
Yeah.
By the early summer of 1741, the crew was so weakened that when a sailor dropped dead on the deck, the others didn't even have the physical strength left to throw the body overboard.
That is just wow.
Out of the original 1,854 men who set sail, Only 188 survived.
It's a devastating loss of life, and we know today this was a vitamin C deficiency. But biologically speaking, why does a lack of one simple vitamin cause a human body to literally fall apart at the seams?
Well, it comes down to two specific vital roles vitamin C plays in the human body. First, it is an extremely strong radical scavenger.
Okay, what does that mean in biological terms?
It means vitamin C neutralizes unstable, damaging molecules in your bloodstream that would otherwise attack your cells, which makes it crucial for protecting your immune and cardiovascular systems.
Right.
But when we look at the sheer physical disintegration of Anson's crew, we have to look at vitamin C's main job, which is collagen production.
So it makes sense if you look at collagen as the biological steel rebar holding the body together. Without vitamin C, the body it stops pouring new concrete and the whole scaffolding gives out.
That's exactly the biological reality. Collagen is a structural protein that forms long, tear-resistant fibers that our cells attach to.
Right.
It makes your bones strong. It acts as cartilage to keep your bones from rubbing against each other. It supports your tendons and ligaments, and it strengthens your skin.
It does everything.
It's so foundational that collagen makes up an incredible 30% of all the protein in the human body.
30%. That is a massive chunk of our makeup.
Huge. And without vitamin C available, no new collagen can be formed. The production line just halts. So when you picture that sailor whose 50-year-old wound broke open, it's because the body is always in a state of continuous maintenance.
Right. It's always rebuilding.
Exactly. Without new collagen forming, the body can no longer maintain the scaffold holding that old scar tissue together. The tissue gives way. The bones can't hold their form.
You'd think arriving in South America and getting cured by fresh fruit would be the ultimate aha moment for humanity. I mean, eventually, those weakened men who survived did go ashore.
They did.
They ate fresh fruit and vegetables, and those foods provided enough vitamin C to quickly alleviate all their symptoms. The scurvy just vanished. But not a single one of those sailors recognized the direct connection between their nutrition and their recovery.
No, they didn't. They just considered scurvy a grim fact of a sailor's life. When they set sail again, relying on those same preserved ship provisions, the symptoms returned. They weakened, more died, and they remained in terrible shape until the next port. Despite this, Anson actually completed his mission. He captured towns, took a silver transport, and returned a hero, but at an almost unimaginable human cost.
And the most maddening part of this history isn't just the disease itself, it's our species' collective amnesia.
Oh, the forgetting is incredible.
Humanity didn't just figure this out once, we discovered and forgot the cure for scurvy multiple times.
The timeline is fascinating. If you go back to 1550 BC, the ancient Egyptians were observing scurvy and theorizing about its cause.
But they had a wild theory, right?
They developed a completely incorrect theory, believing scurvy was due to a lack of oxygen in the tissues. However, the prescribed treatment was acidic foods like lemons or vinegar.
So they were curing people with lemons based on entirely false logic.
Yeah, they had the right solution for the wrong reasons. But that knowledge faded. Fast forward to the end of the 15th century, and Portuguese sailors realized that citrus fruits protected them on long voyages.
You'd assume that would cement the cure into naval doctrine forever, like problem solved.
It didn't. Then, in 1536, French explorers were navigating the rivers of North America. They observed native peoples boiling the needles of certain trees to make a tea.
And that tea was the cure.
That tree needle tea happened to be incredibly rich in vitamin C, and it cured the French sailors who were suffering from scurvy.
It's just a constant cycle of discovery and forgetting. Take the story of Captain James Lancaster in February 1601. He essentially runs a massive, real-world clinical trial.
A huge one.
He sends 4 ships out on a voyage, but he only gives lemons to the crew of one single ship.
A very clear control group.
And the result is entirely predictable to us now. Scurvy spreads like wildfire among the fleet, but all the sailors on the one ship given lemons remain perfectly healthy. Yet somehow, all of these incredibly clear discoveries were lost to time again.
It took another 170 years after Lancaster's experiment for the healing power of citrus to finally stick as medical fact. In 1772, James Lind conducted one of the first formal clinical studies ever recorded. He definitively proved that oranges and lemons were the best remedies against seafarers' disease. And he found the precise dosage needed.
Which was how much?
As little as 10 milligrams of vitamin C daily could protect a sailor against scurvy.
10 milligrams a day. That is such a tiny amount to prevent your body from disintegrating. But this raises an incredibly provocative question.
Okay.
For centuries, human sailors were dying horrific deaths while humanity repeatedly forgot the cure. But if you were to walk below the deck of Commodore Anson's doomed ships, the rats scurrying around the cargo hold were fat, healthy, and completely immune to scurvy.
Right.
Why didn't the ship rats get seafarers' disease?
This is where we uncover the central genetic mechanism at play. Rats, and almost all mammals actually, including dogs, cats, horses, and pigs, they don't need to eat lemons or tree needles.
They don't.
No, they can produce their own vitamin C internally. They manufacture it using something called the GLO gene.
Wait, so if dogs and rats and pigs have this internal vitamin C factory, are we humans just missing this gene completely? Like, did it get left out of our biological blueprints?
Well, scientists looked deep into our DNA to answer that,
Yeah.
and they found that humans do actually have the GLO gene. We all carry it, but it is defective in every single one of us.
So it's just broken.
Exactly. Scientists refer to this kind of genetic remnant as a pseudo-gene. The blueprint is there, but the machinery itself is entirely broken.
How does an entire species end up with a broken gene for something so vital to our survival?
To answer that, researchers analyzed the GLO genes of various animals, including several primate species. They looked at chimpanzees, gorillas, orangutans, and even smaller monkeys, like the palm-sized brush monkey.
And what did they find?
They discovered that many primate species carry this exact same genetic defect and cannot produce vitamin C. Other species, however, have functional GLO genes and produce it naturally.
So something drastic must have happened in our shared evolutionary past, like about 61 million years ago, according to the book.
Right. Researchers assume that the very early ancestors of apes had an intact, fully functioning GLO gene. They produced their own vitamin C, which meant they weren't dependent on a vitamin-rich food supply.
So they could just eat whatever.
Exactly. They lived on a diet of whatever was available in their environment: meat, carrion, insects, and roots. Those foods contained little to no vitamin C, but their internal factory kept them healthy.
Then the environment shifted. These early primate species found themselves in a habitat surrounded by an incredibly high proportion of vitamin C-rich fruit. Suddenly, they had this radical scavenger in absolute abundance.
And the amounts they were consuming completely altered their evolutionary trajectory. Gorillas today eat 30 times more vitamin C per pound or kilogram of body weight than humans need.
30 times more.
Howler monkeys consume about 80 times more. And the absolute front-runner is the spider monkey, which consumes 100 times more vitamin C than is strictly necessary.
The biological logic here is basically use it or lose it. Because these ancient apes were stuffing themselves with fruit all day long, a random genetic mutation that broke the GLO gene wouldn't kill them.
Right, it wouldn't matter.
They were already outsourcing their vitamin C needs to the fruit trees in their environment.
Let's contrast this with rodents to see the evolutionary pressure at work. If a baby rabbit, which is a rodent, is born with a damaged GLO gene, that young animal will rapidly suffer from a devastating vitamin C deficiency.
Because it's not eating all that fruit.
Exactly. A rabbit's normal food supply simply does not provide enough of the vitamin. It would die of scurvy long before it ever had the chance to reproduce and pass on that genetic defect. So in rodents, there is a permanent, intense selection pressure to prevent the loss of the vital GLO gene.
So if a rat's gene breaks, the rat dies. But if a fruit-eating ape's gene breaks, the ape just grabs another handful of berries and feels fine.
Exactly.
Yeah.
Without the evolutionary pressure to preserve the gene, more and more defects accumulated over generations. The emerging gene defect had no negative effect on the health of the animal, so it spread unchecked throughout the population.
Wow.
Eventually, not a single monkey in that lineage was able to produce its own vitamin C. And scientists confirmed this mechanism by looking at bat species.
Oh, really? What about bats?
Bat species that evolved from insectivores into pure fruit eaters no longer have a functioning GLO gene. But the bat species that still feed on insects, they have a functioning GLO gene and produce their own vitamin C perfectly well.
That is fascinating. And uniquely, guinea pigs lost their GLO genes because of their own specific vitamin C-rich diet in their evolutionary past. They lost the ability to make it, just like us.
Yep, just like us.
So our early ancestors happily chewed on fruit 61 million years ago, allowing this vital genetic machinery to rust and break down completely. They could afford this genetic defect because they ate fruit all day, but you and I don't.
No, we definitely don't.
What does this broken pseudo-gene mean for our daily reality right now?
It creates a major biological dilemma. The average human diet has evolved far away from the original massive vitamin C intake of our early ancestors. Gorillas are still filling their bellies with fruit, keeping their biological scaffolding intact. Humans have a serious problem because our natural vitamin C factory is gone forever.
We are permanently stuck with the defective pseudo-gene.
And it is compounded by another biological quirk. We completely lack a storage mechanism for vitamin C.
Which makes sense evolutionarily. Why would your body build a warehouse to store something it thinks it's manufacturing 24/7?
Right. Because we cannot store it, you have to live with the reality that every single dose of vitamin C you consume from food or supplements has a remarkably short half-life in your body.
Because it's water soluble.
Exactly. Because your body thinks it is constantly making it, your kidneys are programmed to aggressively flush the excess out through your urine.
The math on this half-life is genuinely surprising. Let's say you swallow a supplement of 1 gram of vitamin C. It enters your bloodstream. Just 30 minutes later, only 500 milligrams of it are left in your blood.
Yeah.
The other 500 milligrams have already been broken down and filtered completely out of your body.
And the clock keeps ticking. Another 30 minutes later, that remaining 500 milligram dose is halved again down to 250 milligrams. It vanishes from your system incredibly fast.
This is why you can end up in situations where there just isn't enough vitamin C left floating around in your system to form new collagen or to neutralize those unstable molecules we talked about earlier.
Exactly.
The actionable takeaway for your daily life is crystal clear. Because of this defective pseudo-gene, you biologically need to consume vitamin C-rich foods constantly throughout the day. You can't just have one massive dose on Monday and expect your immune system and collagen production to be fine until Friday.
Doesn't work that way.
Right.
Yeah.
If you don't keep supplying it, you are actively depriving your body of the structural rebar it needs to hold your tissues together.
It's a daily, ongoing requirement, dictated entirely by an ancient evolutionary glitch. And, as a fun note from the research, if you happen to have a pet guinea pig at home, keep in mind that they are bad pirates, too.
Bad pirates.
Yeah. Because their gene is also broken, you need to treat them to a little vitamin C-rich broccoli every single day to keep them healthy.
I love that. It is just a wild chain of cause and effect. A dietary surplus of fruit enjoyed by monkeys 61 million years ago removed the evolutionary pressure to maintain a functioning gene.
Right.
That allowed a genetic defect to spread, which eventually led to the horrifying structural collapse of 18th century sailors living on cured beef and biscuits. And today, it continues to dictate the biological reality of how frequently you must eat fresh foods.
It's incredible.
It really is. It leaves me with this final thought. If our DNA is essentially a biological museum carrying the permanent receipts of our ancestors' behavior if an ancient diet of fruit permanently rewrote our genetic capabilities 61 million years ago, what modern conveniences or massive dietary shifts are we engaging in right now?
Oh, that's a great question.
Are there things we are doing today that are permanently rewriting the genetic destiny of future humans millions of years from now?
It really forces us to consider how our current environment will shape the pseudo-genes of tomorrow.
It really does. As we saw with Commodore Ensign's doomed crew, we might think we're operating a perfectly engineered biological machine until we sail right into the muddy waters of a hidden genetic glitch. Keep your scaffolding strong, and we'll see you on the next deep dive.